Hello everyone, welcome to PJ Chemistry channel. Today we are going to discuss physical states of matter in that solid state. Especially we are going to discuss solid state. Solid state. Yes. Physical state of matter. How it becomes a solid state. What are the properties acting on it? That we are going to discuss clearly. First of all, generally if you observe any solid, any object, by seeing that you can say immediately, for example, this is the marker where the physical state of this means immediately every children will say that is solid. If I bring water, they will say that is liquid. If whichever not appear to us but we can feel, that is air. Like that they can identify easily. But how these three states of matter existing, what are the properties acting on it, that we are going to discuss. First of all, if a solid, if you observe, this is the solid, we are telling, how we are telling means, because the particles tightly packed, there is no space between them. Okay, more attraction between the particles. So as per the previous video itself, I said clearly, property existence of matter mainly depends upon two properties: attraction between the particles, space between the particles. So when you have clarity about these two, you can easily answer the every questions. Now see here, so generally solids have fixed shape and volume. Generally solids have fixed shape and volume. Fixed shape or definite shape. Fixed shape and fixed volume. Why they having fixed shape and fixed volume? Fixed shape is nothing but rigidity. Rigidity due to rigidity. What is meant by rigidity? The packing of the particles in that particular physical state. That is we call rigidity. Here, in these particles are tightly packed. In this, particles are tightly packed. Tightly packed means more attraction between the particles. Tightly packing is nothing but more attraction between the particles. So they having more rigidity. Generally, solids having more rigidity. Next, interstitial space or interparticle space. Interparticle space. Space is nothing but gap. Interparticle between the particles, gap. That is only we are telling interparticle space. So interparticle space. Previous videos we discussed already. When attraction is more, space between the particles less. So generally solids having very less space or negligible space between the particles. Generally, solids having negligible space between the particle. There are some exceptions that also we will discuss. This is a general property. Solids having negligible space between the particle. Based on rigidity interparticle space, we can say why solids having fixed shape and fixed volume. Now, what are the exceptions? Except, for example, if we take iron, rubber band, sponge, or cotton. Rubber band, sponge, or cotton, if you observe, rubber band can be stretched. If you stretch, the shape, volume will change. Until stretch only, that will be, it is like a different shape or volume. But once the remove stretch, again it will convert to same position. Even sponge, sponge having small air gaps, or cotton, cotton also having small air gaps. Because of that, it look like more volume, and between the particles more space are present. That we can clearly observe. There are some exceptional cases. So except rubber band, sponge, cotton, even ice cube. There are some examples which is having even the solids, but they having space between the particles. Next, compressibility. Compressibility. Compressibility means applying pressure. When we apply pressure, if the size or shape change means they are having compressibility. If not change means they are not having compressibility. Generally, solids are having low compressibility or negligible compressibility. For example, this is the duster. When I apply pressure on this, no changes. That means solids having no compressibility or low compressibility. Generally, solids have low compressibility, except just now we discussed the low point, power point. What are they? which is having space between the particles, they can able to compress. Yes or no? Because when we compress, that air gaps, air will go out, that volume will get reduced, means shape changed, size changed. So like that, exceptional cases, we can take sponge, rubber band, cotton, cotton as a examples. These are solid substances but compressible. Other than this, remaining generally solids means no compressibility or low compressibility. Okay, but these having high compressibility, even though solids. Next, diffusion. What is meant by diffusion? First of all, diffusion means what? Diffusion means spontaneous mixing another substance into air and flow along with air. That is what we call diffusion. Okay, spontaneous mixing into air and flow along with air are called diffusion. Diffusion. Spontaneous mixing into air and flow along with air or and move along with the air. Along with the air are called diffusion. But generally solids are non-diffuse. Generally solids are non-diffuse. Means when it converts into gas, it will get diffusion. But solid substances, it will not move along with the air. It will not mix along with the air and move. So generally solids having less diffusion. Solids having less diffusion. Generally solids are less diffused. Generally, solids are less diffused or no diffuse also. Why less diffused we mentioned means some solids which are lighter in weight, little bit it will move along with the air at the time. So little diffusion is present. That is, so solids are less diffused. Solids are hard in nature. Solids are hard in nature. That means they having more tensile strength. Tensile strength is nothing but which can take stress and withstand before breaking more time. That is we call tensile strength. So generally solids having more tensile strength. Of course, there are exceptions, same what we discussed, which is having space between them. They can able to break it easily. But general solids are having more tensile strength. That is what they are hard in nature. Because they having more tensile strength. Tensile strength. Next, diffusion. What is meant by, sorry, diffusion over no? Next, density. Density. What is meant by density? Density means mass by volume formula. Mass by volume. So mass of the substance occupied how much volume, based on that they will decide density of the substance. Okay, more mass means occupy less volume. If they are having less mass, they will occupy more volume. That's how we will discuss. For example, generally solids means general point, solids having more density than other physical states. Okay, density of the solids density of the solids are more than other physical states, liquids and gases. But in between the solids only, how density variation based on the solids existence. For example, here I am taking three substances: iron, sponge, before that rubber band, cotton. Just consider all were taken equal weight. All were taken equal weight. 10 grams of iron, 10 grams of rubber band, 10 grams of cotton. But if we observe among these three, we feel just if, without saying anything, if you ask other person, they will say which is having more weight, which is having more amount means immediately they will say cotton having more, because it will appear more amount, even though 10 grams equal to this, but it will appear like a more amount. Then after rubber band, then after iron, they will say the iron will say lesser amount, but look like they will appear like that, but all are having equal weight. We taken 10 grams, 10 grams, 10 grams. Those who are weighing, there was that. But how about density difference between these three? Density means we know mass by volume. Here, iron mass is 10, 10 grams to be taken. It occupy volume only 10 cc, 10 cubic centimeter. Next, so 10 by 10, 10 grams by 10 cc is equals to 1. 10 cancel, 1 gram per cc. Next, rubber band you calculate. Compared to iron, rubber band we feel less weight. Means between the particles, space is there. That we cannot able to see directly, but they are having space. They can easily stretch because of space. So this also mass is same 10 grams, but occupied volume just consider 100 cc. Occupied volume 100 cc. That means how much? 0.1 gram per cc. It's a density. Next, if you come to the cotton or sponge, anyone you can take, either cotton or sponge. 10 grams mass is same, but it occupied 1000 cc. It look like more amount because more space between the particles. Based on space, it will appear the larger amount, like that is only volume we are considering. So here its density is 0.01 gram per cc. Iron 1 gram means iron density is 1. Rubber band 0.1, density of rubber band 0.1 decreased. Weight is same 10 grams, but volume up by different. Cotton 0.01 means still density decreased. So which is having lower density, that is light in weight. That is what? Density of iron is greater than rubber band. Density of rubber band is greater than cotton. Like that, we are going to say in between the solid state only different densities based on the volume occupied. Understood, children? Above previous what we discussed, density is nothing but mass by volume. So calculation part bit confusing to us. Is there any simple way? Means one more way generally we can identify. If you take iron, 10 grams of iron, just take 3 containers which is having same volume. Just consider volume is 1000 cc. Cc is nothing but cubic centimeters, milliliters, 1000 milliliters. Nothing but 1 liter volume. 1000 ml, 1000 ml equal volume container. Now, already we discussed 10 grams each substance. 10 grams of iron occupy very less volume. 10 grams of iron, when I place into this container, it occupies only this much volume. Because their particles are tightly packed, there is no space between the particles. Attraction is more between the particles, so they occupy very less volume. Next figure, I try to put it rubber band into this container. Rubber band occupy more volume. Rubber band occupy more volume. Next, I try to put it cotton in the third container. Cotton occupied almost complete volume of the container. That means having same volume, same mass, but occupying space is different. So more space. Space is that means between the space air occupied. So when air is present in the substance, we feel like a less weight. That is what density of cotton is less than rubber band. density of rubber band is lower than solid, which is nothing but iron piece. Next, what about boiling point and melting point? Generally, solids have high melting point, high melting point, and high boiling point, because the particles attraction is more and space is less. When the particles attraction is more, it requires more energy to break it. So they having more melting point and boiling point. Next, about boiling point, melting point, one more video we will discuss, student. Sublimation. What is meant by sublimation? For many Olympiads, they used to ask this question: sublimation. Sublimation means the process of conversion of solid directly into gaseous state by heating. That is we call sublimation. The process of conversion of solid directly changes into gas without any liquid, without forming liquid. This process we call sublimation. The process of conversion of solid directly changes into gas without forming liquid by heating or its own. That is we call sublimation. The process of conversion of solid directly changes into gas without forming liquid state. That is we call sublimation. Best examples for sublimation: ammonium chloride, NH4Cl. Is nothing but ammonium chloride. Ammonium chloride. Iodine, naphthalene balls, anthracene, camphor, incense sticks, incense sticks, because the bar, incense sticks. These are the best examples for sublimation. What are they? Ammonium chloride, iodine, anthracene, naphthalene balls, camphor, incense sticks. These are the best examples for sublimation.